All right. Happy Tuesday, April 1st. You don't actually have homework. No, I'm just kidding. April Fools. To look up the origin of that, the holiday or something like that. Anyways, okay. Do you see that circle over there? He's really smart. He has 360 degrees. So, um, a degree is obviously something you get from college or when you graduate, associate's degree or bachelor's degree, master's degree, doctorate. But also we say degrees for how you measure a circle, or angles. And so circle is 360, which is an entire revolution. So cool. All right. Today we did some generating patterns and interpreting relationships. This is good stuff. I also just want to remind you of our treasure chest, or what is it again? The forget something load. Anyway, somebody has to remind me. Please, 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 please. I'll give you a ton of beat points if you remind me the next day. I forget what kind of thing it is. Anyways, things that we want to remember are factors, are things like 1, 2, 3, and 6, but multiples are like 6, 12, 18, 24, 30, etc. So those are quite a difference. We also want to know volume, length times width times height. X comes before Y when we're plotting. 2/4 equals 1/2. Division question is how many of blank are in blank? Okay. So we explored some rules and patterns. And one of the things we noticed were that there are some lists that have every single number of the first, like a different list in it. And that's because they are multiples of of a number, and then the first number is the factor of the number. So like in this case with with 2 and 6, 2 is a factor of 6 and 6 is a multiple of 2. That's how those two get related. And the numbers in pattern 1 or rule 1, like in class today, are 1/3 of the corresponding numbers. So I just want to point out that times 1/3 is the same as divided by 3, not divided by 1/3, divided by 3. And then these are triple, which means multiplied by 3. That's this. Okay. And then if pattern 1 had a 40, pattern 2 would have 3 times that. And then if pattern 2 had 240, pattern 1 would have 240 times 1/3, or 1/3 of 240. All right. So hopefully we're making that connection. Okay. So we're going to use each rule and we're going to answer the questions below. 0, 2, 4, 6, 8, 10, 12, 14, 16, 18, and 0, 10, 20, 30, 40, 50, 60, 70, 80, and 90. All right. And the questions are on the back of your page. Which relationship do you notice in between the corresponding numbers in the two patterns? I also just want to point out what corresponding means if I didn't already in class. Corresponding means match. Corresponding, okay, that equals match. That means it also equals same spot. If something corresponds, it's in the same spot. Okay. All right. So which relationship do you notice about the corresponding numbers? The numbers in the first pattern are 2 less. That's not true. That's subtraction. Number in the second pattern are 10 more. Addition, no, that's not true because it's 8 more, or in one case, and 16 more in the next. The number in the first pattern are half the value. Because half of 10 is 5. So it has to be this one. And it's true. It is 5 times the one before it. All right. Tyler's rule. 0, 4, 8, 12, 16, 20. Okay, 0, 16, 32, 32 and 16, it's 48. 48 and 16, 64. I feel like I knew that. 80. All right, so let's answer the question. What relationship do you notice between? Okay. Well, Cynthia's rule is 4 times Tyler's rule, or Tyler's rule is 1/4 of Cynthia's. Okay, I'm so sorry. I know I should write in print. Okay, Cynthia's rule, that's the word rule, is 4 times Tyler's rule, or Tyler's rule is 1/4 of Cynthia's. Okay, so hopefully that's helpful. If the patterns continue, what number will be in Cynthia's pattern when Tyler has 72? All right, so this is, I like to do Tyler, Cynthia, because this is, it's 1/4, and then Cynthia's missing when Tyler has 72. So if we're going for Tyler, we're going to do 72 times 4, because Cynthia's is 4 times Tyler's rule. 72 times 4, 8. All right. Cynthia has 288 when Tyler has 72, because her numbers 4 times Tyler's. Okay. And then we're going to use the figures below to answer the questions that follow. All right. This is a little bit of a review. I like that other stuff. Use the figures below. Okay, which triangles are right triangles? Well, a right triangle has one right angle, so it looks like it's A and C. Isosceles means 2 sides equal. So it looks like it's B, D, and E. Which triangles are classified as acute? It's going to be B and E. This has all acute angles, and this has all acute angles. If you forget what an acute angle is, a cute little angle, it's more spelled, is less than 90 degrees, because a right angle is equal to 90 degrees. And there's that degrees again, which is really funny. And obtuse is greater than 90 degrees, but less than 180 degrees, which is a straight line. This is 180 degrees, just like 180, like that. Anyways, we can get definitely into that soon. It's good stuff. All right. We also found more complex patterns. I think this stuff is pretty cool. If pattern 1, so let's pay attention to it. It is, ooh, what's happening here? 6s in the pattern 2, 4, 10. Hmm. Hmm. Well, this is adding, okay, so this rule is start at 0, add 2. This is start at 4, add 6. Okay, if I can extend the pattern by counting by 2s until I get to 26, I will continue counting by 6 until I find the corresponding number. Okay, so there was no like multiplication or division here, because this didn't start at a 0, and there's just like no like normal thing. This is times 5. This is times 4. This is times mixed number, mixed number, mixed number, mixed number, mixed number. Again, mixed number, mixed number. I actually don't see any, maybe 24 to 70. Nope. No, because it would be less, right? It would be 70. Yeah, it would be like 72. 20. No, so it's just continuing the pattern until you get there. Okay. Let's look at this one. Generate patterns for the two rules. Start at 0, keep adding 3. 0, 3, 6, 9, 12, 15, 21, 24, 27. Start at 2 and add 3. 5, 8, 9, 10, 11, 12, 13, 14, 17, 20, 23, 26, 29. When the first pattern, whoa, has the number 186, what will be the corresponding pattern? Explain how you know. Okay, well, all right, if I'm at, so let's see how many 27s can go into that, and then we can then treat it that way. So like 27, let's try 27 times 5, maybe 35, 10, 11, 12, 13. Okay, so let's try 27. So I'm trying to get to 186. I could just divide though, and that's perfectly fine too. But right now I'm going to try times 6, 42, 12, 13, 14, 15, 16. Getting closer, maybe 27 times 7, 49, 14, 15, 16, 17, 18. Yeah, see, it went over. It's the weird part. All right. Do I have to just keep going, I guess? First pattern has a number 186. All right, let's see. 27, 27, 5, 27, 8. I got 162, 27, 9, 8. Okay, well, this is the 1, 2, 3, 4, 5, 6, 7, 8, 9. This is the 10th number. 10th number. All right, well, okay, it can go to 189, then it'll go backwards. All right, so the 10th number, how about the 20th number will be 27, will be 54, right? Because this would then be 30, 33, 36, 39, 42, 45, 48, 51, 54. Okay, 57. I'm gonna put 57 right here, and that's the 20th number. And then 57, I'm just gonna count them out. 60, 63 after all that, 66, 69, 72, 75, 78, 81, 84, 87. All right, 90. Oh, there's some sort of pattern here. 93, 96, 99, 102, 105, 108, 111. I see a pattern now. Hold on. 111. Adding 30. Okay. So I'm adding 30. Let's just 111, 114, 117, 87, 97, 07. Yeah, so okay. So I'm adding 30. So 117 plus 30. See how much fun this is? I think it's really fun. 147 and 30 is 177. Oh my gosh. 177. And plus 30, 7, 10, 2. Okay, well, let's go from 177 to 180, 183, and then 186. So I've gone my 20th, 20, 30, 40, 50, 60, 1, 2, 3. It's the 63rd number. Okay, so for rule one, taking a while, and that's okay. I just hope that everyone sticks with me because this is it's really important to be able to show how you're solving something. All right, 29, 30, 31, 32. I wonder if this is going to be 35. Whoa, 38, 41, 44, 47. Do you see the pattern? 50, 53, 56, 59. Okay. Interesting. All right, so that's the 20th, 10, 20. The 30th would be 89. The 40th would be 1119. Okay. The 50th would be 149. The 60th would be 179. 60. Okay, so 179. Okay, so this rule one, 63rd number. Rule two, number 61, 62, 63. 60 was 179, 182, 185, 188. Oh, well, that makes sense. It is two, just two more. Oh my goodness gracious. Rule number two would have the number, oh, kids, I hope you stuck with me. 189 because it's, oh, because rule two, it's are terrible. Don't use it's. Rule two is two more than rule one. Crazy. I'm so sorry. Tell whether each statement is true or false. Show your thinking. When the second pattern has the number of 80, the first pattern, no, that is false. Because the second pattern, now that we know, is two more. When the second pattern is 53, the first, yes, true. 51 plus 2 equals 53. Oh, kids, I'm so sorry. Young people, young adults. Yikes. All right, I'm going to speed through this for us. Hope you fast forwarded it. Ay. Below are two rules in the beginning of their pattern. Adding 30, adding 5. Select all the true statements about the patterns. All the numbers in Cynthia's pattern are in Tyler's pattern. Yes, that is true for A. Each number in Tyler's pattern is one, no, because it's 6 times. This is, so it's times 6 this way, or Tyler's is 1/6 of Cynthia's. Okay, each number is Cynthia. Oh, wait, no, then this is right. Hold on. In Tyler's pattern, yes. Oops, yes. Because Tyler's is, no. Cynthia's, oh my goodness gracious. See, but you just have to think through it, is 1/6 of Tyler's. All perfect examples of working through it. So Tyler's no, because Tyler's is 6 times. So this is also wrong. This is already wrong. Each number in Cynthia's, yes, that is true. The number 90 will be in both. Add 5, yes. Yes, because 5, 10, 15, 20. Yes. So A, C, and D. Consider the pattern 5, 7, 9, 11, 12, 11, 13. Which numbers will be in the pattern? 13, no. 15, 17, 19. They're odd numbers, off by 2. 19, right? Yeah. Quadrilateral. I love that. Okay. Select all the true statements about quadrilateral. All squares are, all right, so like here's the square, then the rhombus, then the parallelogram, and then the trapezoid. Okay. So, and then the rectangle is in here. Okay. All squares are rhombuses. That's true. All squares are rhombuses. All rectangles are square. Not true. All trapezoids are rectangles. Not true. Oh, yeah. Okay. And then the parallelograms are yes, because the one set of parallel sides and 2 sets. So then, oh my goodness gracious. If you stuck with me, tell me, and I'm happy to give you a treat. You're awesome. Bye bye.